Day 22. Our time together is almost over. How many cubes are on? Okay. Arcticore, three-dimensional grid of cubes. Just keep these on or off. Start the reboot process, they're all off. Could it be an old model? Reboot the reactor, you just need to set all the cubes to either on or off by following the list of reboot steps. Your puzzle input, each step specifies a cuboid. Set of all cubes that have coordinates which fall within the ranges for XYZ, and whether to turn all the cubes in that cuboid on or off. For example, given these steps. First step, on x 10 to 12, y 10 to 12, z 10 to 12, turns on a 3x3x3 cuboid. Second step turns on a 3x3 cuboid that overlaps with the first. Sure. Turns on a single cuboid. 39 are on. Initialization procedure only uses cubes that have x, y, and z positions of at least minus 50 and at most 50. For now, ignore. For now, always a hint. Ignore cubes outside this region. Alright, so the idea is that we need to run these instructions. And the first thing it wants to know is how many cubes are on. So in this first set of data, we should get 39. Okay. So parse instruction for the line. Our instruction looks like on or off, and then an X range, a Y range, and a Z range. All right, so let's do record instruction, bool state. We'll use longs, even though they're probably ints are fine for now. Start X and X, start Y and Y, start Z and Z. And this is obviously going to return an instruction given a line. Okay. So we split on spaces. Pieces is, let's see. Yeah. So line split. Yeah, let's go divider. Let's just call it divider. Is line index of space. We have instruction results. Turn the results. And that is use of unassigned, that's fine. Results state is line sub 0 to divider equal to on. Okay, and I can't do this Y, init only properties. This is a record, sure. And you're going to want more stuff. And the rest of these are separated by commas. All right. Is line of divider plus 1 onwards, which of course for reasons unknown requires a parentheses. And we'll split on commas. Yeah, okay. Let's see. We'll say start X, end X. It's going to be able to parse the range of pieces sub 0. So start Y, start Z, and Z, and Y, pieces 1, pieces 2, and then long start, long end, parse range, string value. We'll do value split on dots with a string split options. Remove entry empties. Alright, then we'll return long parse pieces 0, long parse pieces 1. Alright. Start X, end X, start Y, end Y, start Z, end Z. Just to make sure. So this is X equals, so we want to skip the first 2 characters of that. So from 2 on. Alright, that should get us our instructions. Let's take a quick look at our instructions and make sure they look good. Okay. So on from 10 to 12, 10 to 12, 10 to 12, on 11, 13, 11, 13, 11, 13, off 9, 11, 9, 11, 9, 11, on 10, 10, 10, 10, 10, 10. Looks good. Alright, so they're going to tell us that later we are not going to be able to do this, but sure, let's try this. Let's say we have a set, hash set. Alright, a hash set of coordinates is going to be these. Alright, for each var instruction and data, if data state, no, if instruction state, otherwise this. We'll do for each, no, we'll do for x is instruction, start x, x is less or equal to instruction, end x, x plus plus. We do this 3 times with y and z, y and z, y and z. If we want it set, and we're going to say on dot add. Oh, this is XYZ. My bad. All right, XYZ. Why not? What is the problem? Uh-oh, what's going on here? Can I convert from long to int? That's true. Actually, we went the wrong way here. This is what needs to be long. All right. Okay. Otherwise, on remove XYZ. All right, so then return on count. Yeah. 6. Don't believe it. XYZ. Okay. Let's see. What do we do wrong here? Don't care about that. Okay, so our first instruction is on 10 to 12, 10 to 12, 10 to 12. All right, so this should be 10, 10, 10. Actually, let's put the breakpoints here, not there. So on 10, 10, 10, 11, 12, 11, 12, 13. Okay, yep. Plus the wrong things, and, you know. Okay, that should get us 39. Okay. That's fine. So we have a longer example. Last two steps are fully outside the initialization procedure area. All other steps are fully within it. After executing these steps on the initialization. So for now, we have to ignore those cubes, which means we just say if x is less than or equal to minus 50 and x is greater than or equal to 50 and y is less than or equal to negative 50 and y is greater than or equal to 50 and z is less than or equal to negative 50 and z is greater than or equal to 50. All right, then we have this. Now, given this input, we have stuff to ignore. 590,784 cubes. Okay, that's slow. Where exactly are we being slow? Is it these big ones? Well, I mean, obviously I could ignore the easier way. Whoops, that is not what I wanted to do. Whatever. Okay, so rather than doing this here, we could do math min of negative 50. All right. Math max, sorry. And this one is math min of 50 and that. Math max, negative 50. Math min, 50. Math max, negative 50. Math min, 50. I mean, I can see what's going to happen here is we're going to end up with a giant problem space that's not possible to solve. 590,784 in the limited amount of time we have for part 2. That's okay, though. We'll get our real puzzle input here. And get our answer. Okay. Now that the initialization, you can reboot the reactor. Starting with all the cubes off, run all the reboot steps for all the cubes in reactor. Consider those reboots. After running the reboot steps, blah through blah, cubes are on. Just for fun, 474,140 of those are also in the initialization procedure region. Starting again with all cubes off, execute all reboot steps afterwards, considering all cubes, how many cubes are on. Right, so this is exactly what I expected. So now we have a new set of sample data. But we actually have to make it run over this giant data set. Where's my data? Where'd my data go? Okay. And one assumes that If I were to try and run this like this, it wouldn't work. So the essence of this problem then is going to be, what is a good representation of large swaths of data that is on and off? Yeah. Because obviously having a giant hash set over even this sample data is clearly not going to work for me. Especially not on a triple loop like this. Okay. So all the breakpoints can go away. So what is a reasonable set of data? So if I run this sample data, 474,140, that is what it said it would be. 474,140. All right, how can I count all these cubes? Well, this is an interesting one. Let's see, how to represent large sets of on or off pixels extremely efficiently. That's clearly not the question I want to ask. How do I manipulate a large number of pixels? Okay, well, maybe this is the right answer. I think part of the problem we have to anticipate is that, obviously turning on a block of pixels makes a cuboid without holes. But turning off a group of pixels cuts into potentially one or more cuboids. So can we turn them on and off like that? I mean, by the way, these aren't necessarily in min-max order either. Or are they? Actually, they are. But, like, this is a giant cuboid, right? So what if what we stored was cuboids, but each cuboid was, here's me, and then here's everything that's been removed from me. So we'd be looking at like an intersection, right? So we'll do this in 2D space. So let's say we have fill is going to be solid fill. Okay. There we go. So if we have a cube, like we'll do this in 2D space, right? So if I have that, go away, and then I cut out like this piece, right? So basically what I want to do is when I turn pixels off, I want to go find the cuboids that it intersects with and basically represent the piece that got turned off as another cuboid. And then when I go and count, essentially we're going to do what is on, off, off, on. What's interesting is that, like with the simple data, right, they warn us about this idea that you can have overlaps. And I'm trying to figure out how to effectively model that as just these instructions. Do I do a running count? Is that the most effective way? Because if you turn on a cuboid, you could just do the same kind of an intersection with everybody else, right? Except, just don't know. Yeah. I'm not 100% sure how to represent this. Yeah. Oh. What is going to be... There's got to be like a... how to store massive black and white image efficient. That's an interesting one. Okay, no, that's not going to help us. Maybe I should use the word monochrome here. So my notion of storing things as cuboids where you would add and remove things might actually work in the overlap case, because what you do is it's just like the math just becomes really hard for me to reconcile. So what I was thinking was you could store, like if two cuboids overlapped a little bit, what you could do is when you store the second one, when it overlaps with the first one, you just actually cut out the piece of the second one. But then I kind of feel like if they overlap, what I really want is an efficient way to describe the overlap. And obviously I can't just store it as a single pixels because the thing is gigantic, right? All right, nothing bigger than 5 digits, but that makes it pretty explosive in terms of storage. Even just running through the numbers without actually doing any math before was slow. Actually storing things would be really bad. Oh. I'm curious where I landed. So lots of people got that one pretty easy. Do I know anybody who's done with it yet? No. So it's obviously not a simple problem. Okay. Is it a matter of splitting the cuboids up when they get cut into? All right, let me do the paint thing again. Let me see. Let's do this. All right, let's say you have a cuboid that looks like this. Right. And then you slice a piece out of the middle. Right, you slice a piece out of the middle. Like that. And then everything else is just a degenerate case of that. What you end up having then is really 9 pieces, right? Because what you end up, like, if we think about, I'll cut it out. Don't be dumb. So you have everything on the top. Yeah, whatever, let's do an airbrush. So you have everything on the top. Right? That becomes 1. And then everything on the bottom becomes another one, right? And then you have individual pieces here where it's like you have the front piece here, and then the back piece here, and then the side piece here, and the side piece here. So kind of at most you end up with 6 parts. And if you don't have it directly in the middle, then you end up with fewer, because as you sort of make these things, then they go away. And now, so that's the negative version, right? What about the positive version, where I have another overlap? So I make, for example, I make another one here that overlaps like this, right? And then let's say it goes, like that far in, right? So we've got this overlap here now. Essentially, then what you're doing with an overlap on that is, right, there are pixels here that are already on. So it's like kind of like you cut out the overlap. You do kind of the same thing you were doing elsewhere. Like you consider this to be negative space for this. Like this is cutting out pieces of that. But the problem is like if you've got a hole in the middle of, so like if you got a hole in the middle of that, then I guess you can't have a hole in the middle of it, because a hole in the middle of it makes 6 new pieces, right? And so you're finding all the intersections and basically saying anywhere where a new piece intersects with an old piece, it gets cut out of the new piece. It's just not part of the image anymore. Or you could leave them there. You don't want to leave them there, because when it comes time to count, then you've got a double counting problem. So you definitely don't want to leave them there. I don't think I'm any closer to solving this than I was before. I'm going to assume that this data is just not going to run. Oh, I don't need to do that. I don't know why I opened that up. I'm going to assume this data isn't going to run. But for curiosity's sake, I'm kind of curious to know how bad it gets, right? And do we just fall over at some point? I mean, I feel like we probably fall over at some point. So here, I want to say, pencil right line, x equals instruction start x, right? Start x to instruction end x, y equals instruction start y to instruction end y, z equals instruction start z to instruction end z. just to see how fast we're making it through these things. My guess is... yeah. Right, that's just going to be too slow. And we're probably going to run out of RAM at some point. Right. I kind of watch the RAM climb. Yeah, that's obviously not going to work. All right. Well, I don't have an idea, is really what the problem is. I don't have an idea. So I think I'm going to have to do what I have done a lot in the last few days, which is end the stream and see if I can come up with an idea. I don't know, maybe some Warframe will inspire an idea for me while I'm bullet jumping all over the place. Yeah, because nothing is coming to mind. I want to fix this problem. I mean, we knew this was not going to be a solution for part 2. Alright, well, no sense sitting here trying to think. That doesn't really make any sense, so... I guess I'll see you all tomorrow. And when you join me tomorrow, we'll find out whether or not I thought of anything or not. Because this could be the day that breaks me. You never know. Alright, all. Well, have yourself a good time. And if you're trying to solve this problem, good luck. I don't know what to do. See you.